Welcome to all of you, users of the CWS Electronic channel. At this course, I am to teach the construction of linear power supply so that you can build different type of power supply boards. Why this course called Building a Linear Power Supply for Repair Technician? This course is beneficial for those working in electronic repair, especially for those repairing household appliances. It will help them become familiar with the power supply boards, allowing them to repair and necessary design and build their own boards. So in addition to repair skills, this course will also introduce you to designing and building power supply boards. So stay with me. In today's world, one of the important and profitable professions is in the field of the electronics, such as the repair and troubleshooting of household electronic appliances. For instance, when there's an issue with the device, consumers often prefer to have it fixed rather than buy a new one. In this course, you will learn how to build the power supply boards for appliances like refrigerators, washing machine, and more, and even how to sell them. The session is an introductory and foundational one. I will begin by familiarizing you with some basic and important concepts in electronics to ensure you're prepared for the course. It's recommended that you have a basic understanding of electronics before starting. If not, I suggest you first learn introductory electronics and then join this course. The key point is that once you become familiar with the process of building linear power supply, which are present in most household appliances, and gain deeper knowledge, you will be able to repair any type of power supply. And if it's beyond repair, you will be able to build one for the device yourself. This will increase both your income and your skills. In this training course, we will explore different types of linear power supply, starting step by step with building simple ones and gradually moving on to more advanced power supplies. So, let's get started. The first thing an electronic specialist needs to know is how clearly describe and understanding concepts such as the current, voltage, waves, half waves, and more. We will also begin with this course, starting with voltage. What is voltage? We all know that electricity is the result of the movement and pressure of electrons, which is referred to as potential difference. Different materials have a different structures, leading some to have an electric charge or to be able to free their internal electrons, allowing electricity to pass through, while others are insulator where electrons do not move. Materials that have free electrons are called conductors, are further divided into two main categories. One group loses electrons and the other group gains electrons. In some cases, both processes can occur simultaneously, as the group that loses electrons must receive them again. This creates a continuous chain of movement, and the flow of these electrons generates an electric current. In an electric current between 2 points, the greater the number of electrons, the more pressure they exert. This pressure is what we call voltage. So, when there is a high number of electrons and their pressure in a path, it is referred to as voltage. Electronics is the science of designing circuits to control and direct the movement of these electrons. This way, devices are created to perform specific functions, which is a true and accurate definition of this field of electronics. Now, let's discuss current or amperage and see what is the current definition is. When electrons move from a point to another, in addition to potential difference or voltage, they also have a current flow. This means they have a speed of movement, which is referred to as a current intensity or amperage. The symbol for current is I, and its units of measurement is ampere, represented by A. We can compare current intensity to water flowing through a pipe. The faster the water through the pipe, the higher the current intensity will be. Voltage and amperage are closely related. As voltage increases, current intensity decreases. However, it is possible to adjust voltage and current to a certain extent, but not indefinitely, due to a constraint imposed by physical laws, which are not our focus here. Next, we come to the term watt, which you have likely heard a lot about. You might have heard the statements like a device consumes this amount of watts, or this power supply is 50 watts. In simple terms, 1 watt described the amount of power and is always denoted by the letter W. When a current of 1 ampere flows with a voltage of 1 volt, the result is described in watt. This is why power supply and other devices are rated in watts. The formula used is voltage times ampere equal watt. To illustrate this more deeply, if you have a battery with a voltage of 1 volt and a current of 1 ampere, its power is 1 watt. For another example, if you have a power supply that provides 12 volts and 10 amperes, its power is 120 watts. So, if you have an adapter that is 12 volts and can supply up to 10 amperes, its power is 120 watts. If you have a power supply with a current rating lower than 1 ampere, for example 500 milliamperes, you need to convert milliamperes to ampere. Up to this point, you have understood the relationship between watts, voltage, and ampere. Now to understand why an electric heater results in high electricity bills. It's because such heaters typically comes with around 2000 to 3000 watts. Using the formula provided, you can calculate how much current they draw. In contrast, a typical freezer may consume up to 10 watts, or a washing machine may consume between 500 to 1000 watts. So far, we have covered a simple definition of voltage, ampere, and watts. In the next session, we will discuss waveforms and concepts like DC and AC, helping you understand the shape of electrical current wave. You will also learn about half wave, full wave, negative voltage, positive voltage, and more. These concepts are crucial for understanding power supplies, and it's essential to learn them.